Okay, let's look at some examples of finding absolute extrema. And we're going to start with number 6 from your homework. My function is x plus 4 over x. And you'll notice it gives me a closed interval. So I'm going to restrict my domain to just between 2 and 10. That's the only spots I'm looking for this absolute minimum and this absolute maximum. We know from our concept video that if I restrict it to a closed domain, I'm guaranteed to have an absolute max and an absolute min within this domain. Since I know I'm going to have some, where can these possibly occur? I know that I can potentially have my absolute max or my absolute minimum at the endpoint. So I'm going to put both of those x values down as my possible absolute extrema. But they can also occur at my critical points. So what I'm going to do is I'm going to look at my function and I'm going to take the derivative to find my critical points. So what's the derivative of this function? Well, since I'm separated by addition here, I can just look at each of these terms separately. Derivative of x is just 1. But 4 over x, remember I can rewrite that as 4x to the negative 1 power. If your x is in the denominator, you can move it to the numerator and give it a negative exponent. So my derivative of that gives me negative 4x to the negative 2nd power. And then I'm going to set that equal to 0 to find my critical points. Well, to help me solve this, I'm gonna rewrite this back as putting that exponent back into the denominator. I'll add 4 over x squared to both sides. That gives me this. And then I can multiply both sides by x squared. Now I can square root both sides, and I get x is equal to positive or negative 2. So this gives me 2 possible critical points, positive 2 or negative 2. But what do you notice about negative 2? Negative 2 is not within my domain. Only positive 2 is. So I can ignore the negative piece because of my domain. My domain is only between 2 and 10. Now, some of you guys may have been watching that process and may be screaming at me saying, "You missed something, Mr. Johnson." And you're right, there's an important thing that I ignored here. Let's go back to my original derivative. Are there any x values that will make this derivative undefined? Remember, those also count as critical points. It turns out if x is equal to 0, I get an undefined value, right? F prime of 0 is equal to 1 minus 4 over 0 squared, which I now have 0 in the denominator, which is undefined. So this also counts as one of my critical points. But what do we notice about that? It's not within my interval. So negative 2 and 0 are both not within my closed interval, and therefore I don't have to worry about those points. They can't be my possible absolute mins or absolute maxes because they don't fall within my closed interval. The only one that does is positive 2, but guess what? Positive 2 just matches one of the endpoints that I already had. I was already planning on looking at positive 2. So what's nice about this example is it doesn't give me any additional points to check. The only critical point that's inside my interval is already one of the endpoints. So for this example, I only have to check 2 and 10 to decide which one's my absolute minimum and which one's my absolute maximum. To do that, I'm just going to plug it into my function. So when I plug 2 into my function, I get 2 plus 4 over 2, right? My function is x plus 4 over x, and that just gives me 4. When I plug 10 into my function, I get 10 plus 4 over 10, which just gives me 10.4. So my corresponding y value for 2 is 4, and my corresponding y value for 10 is 10.4. Since 4 is less than 10.4, this represents my absolute minimum. And this represents my absolute maximum. And I know that there's no point in between that can be my absolute minimum or absolute maximum because there's no critical points in between 2 and 10. There's no spot where my graph switches from increasing to decreasing. My graph is just always increasing from 2 to 10. And therefore, the lowest point is at the first endpoint, and the highest point is at the second endpoint. So when I actually type in my answer would be f of x has an absolute maximum of 10.4 at x equals 10. And then similarly, I'd say I have an absolute minimum of 4 at x equals 2. So just to review, if you're given a function with a closed interval, you can possibly have an absolute min or an absolute max at your endpoints, or any critical points that are within that interval. And in this case, we only had one that was in the interval and it matched one of my endpoints anyway. Well, let's look at another example. Next, let's look at number 7 from your homework. And number 7 is really asking the same exact thing. Find the absolute maximum and minimum values of this function. But you'll notice a little bit extra, some extra stuff that's within this problem. First of all, it says this, if they exist. Well, remember, if I have a closed bounded interval, then they're guaranteed to exist. So the only way it's possible that they don't exist is if I don't have an interval. And sure enough, with this function, no interval is specified. And so it tells us to just use negative infinity to infinity. So this example is different from all the other examples on your homework because it does not give you a closed interval. It's asking me what's the absolute maximum and absolute minimum value for this quadratic function from negative infinity to infinity. So there's a chance that I might not have an absolute maximum and I might not have an absolute minimum. But the process that we used in the last example still works here. Where should I look for my absolute extrema? Well, before, I wanted to look at my endpoints. But in this case, my endpoints are infinity and negative infinity. Well, let's still look there. But I also want to look at any discontinuities my function might have. Why do I need to look at discontinuities? Well, if you have a discontinuity, remember that there's a chance that you might have a vertical asymptote. You might have something like this. And if you have a vertical asymptote, then what's your absolute maximum? There is no absolute maximum. You're guaranteed to not have an absolute maximum because your function is going off to positive infinity, or it's going off to negative infinity, meaning you don't have an absolute minimum. But if you look at our function, it's a polynomial. And we know that polynomials are continuous everywhere. So this function doesn't have any discontinuities. Well, the last point I need to look is at any critical points. So to find my critical points, I need to take the derivative. My derivative is negative 4x plus 56. If I set that equal to 0, I can solve for x. I'll subtract 56 onto both sides, and I get negative 46 is equal to negative 56. I'll divide by negative 4, and I get x is equal to 14. So I have one more spot where I could potentially have an absolute max or an absolute min. So now let's see what's happening to the y value at each of these important points. What's happening as I let x get infinitely large? Well, notice I have a negative in front of my leading term, meaning which way is this parabola facing? This is a downwards facing parabola. So if I let x get infinitely large, that largest term is going to dominate, and I'm going to be left with negative infinity. So this function is approaching negative infinity as I let x get infinitely large. Well, what if I let x get infinitely negative? What if I let it get infinitely large in the negative direction? Well, once again, this highest term is going to dominate. And when I square a negative number, it becomes positive, and then that negative coefficient means that the y value is going to be approaching negative infinity again. So in both directions, my function is approaching negative infinity, and which makes sense because like we already said, because of that negative coefficient, we know it's a downwards facing parabola. So what does that already tell me about this function? Since I'm going down to infinity in both directions, there is no absolute minimum. But because it's a parabola, I should have an absolute maximum. Where is that absolute maximum occurring? At your critical point. So, what's f of 14? When I plug 14 into my function, I get positive 52. So, there's your absolute maximum. Absolute maximum is occurring at your critical point because that's the vertex of your parabola. There's an absolute maximum of 52 at x equals 14. Okay, let me know if you have any questions on any of the other problems. But good luck with the rest of your homework, and I'll see you in the next video.